Hello! In this video, we will talk about 12 must-know topics before taking your first calculus class. So let's start with the first one. And this is the slope of a line. The concept of slope is extremely important in Calculus 1. And here you need to know that if you have a line passing through 2 points x sub 1, y sub 1 and x sub 2, y sub 2, then the slope is calculated using the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what the slope is, it is change in y over change in x, which is rise over run. So if we have 2 points, 2, 4 and 7, 6, then the slope is going to be change in y, which is 6 minus 4, over change in x, which is 7 minus 2. So we can write that m equals 6 minus 4 over 7 minus 2, which equals 2 over 5. We also need to know that if a line is increasing, then the slope will be positive. But if a line is decreasing, the slope will be negative. A horizontal line will have the slope 0, and a vertical line will have the slope undefined. Now, let's say we have the rectangular coordinate system, and in this system I will draw a few lines that pass through the origin. The first line will pass through the point 5, 1. Then we can say that the slope of this line is 1 over 5 because the change in y is 1 and the change in x is 5. Now let the next line pass through the point 4, 2. Then the slope of this line will be 1/2 because the change in y is 2 and the change in x is 4, and 2 over 4 is 1/2. The next line will pass through the point 3, 3. Then the slope of this line will be 1 because the change in y is 3 and the change in x is also 3, and 3 divided by 3 is 1. Now let the next line pass through the point 2, 6. Then the slope of this line will be 3 because the change in y is 6, the change in x is 2, and 6 divided by 2 is 3. And now let one more line pass through the point 1, 8. Then the slope of this line will be 8 because the change in y is 8 and the change in x is 1, and 8 divided by 1 is 8. So notice that if a line is horizontal, the slope will be 0 because there is no change in y. But if we raise this line, then the number that represents the slope starts increasing. Also notice that the line that has the slope 1 forms a 45-degree angle with the horizontal. And as the lines get steeper and steeper, then the slope will increase and will approach infinity. And for a vertical line, the slope is undefined because while there is change in y, there is no change in x. The next topic is the point-slope form and the slope-intercept form of the equation of a line. So if a line has the slope m and it passes through a point x sub 1, y sub 1, then the point-slope form is y minus y sub 1 equals m times x minus x sub 1. For example, let a line have the slope 3 and passes through a point 2, 5. Then to write the equation of this line, in the point-slope form, we will replace m with 3, x sub 1 with 2, and y sub 1 with 5. So we will have y minus 5 equals 3 times x minus 2. We can also remove the parentheses and solve this equation for y. So we will have y minus 5 equals 3x minus 6. And if we add 5 to both sides, then y equals 3x minus 1. Now this form is called the slope-intercept form. And this form is y equals mx plus b, where m is the slope and b is the y-intercept. So if we graph this line, we know that it will cross the y-axis at -1 and it will have the slope 3. So on the y-axis here is -1, then we can use the slope to plot another point. Because the slope is 3, from this point we will count 3 units up and 1 to the right and plot another point. Then we will connect them to get the line. Now, the next topic you will need to know before taking a calculus class is factoring polynomials. When factoring polynomials, first check if there is anything to factor out. So again, first factor out the greatest common factor if possible. For example, let's say we have the polynomial 5x cubed plus 15x squared. This polynomial has two terms, and the greatest common factor is 5x squared. Then to factor, we will need to factor out 5x squared. Then inside the parentheses, we will have x plus 3. And indeed, 5x squared times x is 5x cubed, and 5x squared times 3 is 15x squared. And now we have a product of 5x squared and x plus 3. Now, if you have a polynomial that is a binomial and you need to factor it, then one of these formulas might work. The first formula is the difference of two perfect squares, and this is a squared minus b squared equals a plus b times a minus b. So if we have a difference of two perfect squares, for example, x squared minus 49, then we can factor it as a product of a sum and a difference. So x squared minus 49 is x plus 7 times x minus 7. However, if you have a sum of two perfect squares, then such a binomial cannot be factored, and we say that it is prime. So x squared plus 49 cannot be factored, and this polynomial is prime. If a binomial is a sum of two perfect cubes, a cubed plus b cubed, then we can factor it as a plus b times a squared minus ab plus b squared. For example, the binomial 8x cubed plus 27 is a sum of two perfect cubes, and we can write it as 2x to the third power plus 3 to the third power. Then if a is 2x and b is 3, then we can factor it as 2x plus 3 times 2x to the second power minus 2x times 3 plus 3 squared. Then we can bring down the first parenthesis, 2x plus 3. Then in the second, 2x to the second power is 4x squared. 2x times 3 is 6x, and 3 squared is 9. Now to the right, if a binomial is a difference of two perfect cubes, a cubed minus b cubed, then we can factor it as a minus b times a squared plus ab plus b squared. For example, 64x cubed minus 125 is a difference of two perfect cubes, and we can write it as 4x cubed minus 5 cubed. Then if a is 4x and b is 5, then we can factor it as 4x minus 5 times 4x squared plus 4x times 5 plus 5 squared. Then this equals 4x minus 5 times 4x squared is 16x squared, and 4x times 5 is 20x, and 5 squared is 25. Now, if we need to factor a polynomial that has 4 terms, then we can try grouping. For example, let's say we have the polynomial x cubed plus 4x squared plus 3x plus 12. To use grouping, we will have the first 2 terms in one group and the last 2 terms in another group. Then, in the first group, we will factor out the greatest common factor, which is x squared. Then inside the parentheses, we will have x plus 4. Now, in the second group, the greatest common factor is 3, and in parentheses, we will also have x plus 4. So now we have a sum of 2 terms, and they both have a common factor, x plus 4. So now we can factor out x plus 4, and in the second parenthesis, we will have x squared plus 3. So from the first term, we brought down x squared, and from the second, we brought down 3. Now, what if we need to factor trinomials? If a trinomial is a perfect square, then we can use these 2 formulas. The first one is a squared plus 2ab plus b squared is a plus b squared. For example, the trinomial x squared plus 10x plus 25 is a perfect square. Then we can factor it as x plus 5 to the second power. The second formula is a squared minus 2ab plus b squared equals a minus b squared. For example, the perfect square trinomial 9x squared minus 42x plus 49 can be factored as 3x minus 7 squared. Now, if we need to factor a trinomial that is not necessarily a perfect square, but it has the leading coefficient 1, then we can try the sum and the product. For example, the trinomial x squared plus 5x plus 6 is a trinomial that has the leading coefficient 1. This trinomial will factor as a product of 2 binomials, where the first term will be x. Then we need to find the 2 numbers whose sum is 5 and the product is 6. These numbers will be 2 and 3. So if we add these 2 numbers, we will get 5, and if we multiply them, we will get 6. So then, this trinomial factors as x plus 2 times x plus 3. Now, what if we have to factor a trinomial whose leading coefficient is not 1? For example, 3x squared minus 4x minus 4. In this case, the leading coefficient is 3. Then, to factor such a trinomial, 2 of the most used methods are trial and error, or sum, product, and grouping, also called the AC method. To use the trial and error method, we will start with 2 sets of parentheses, and now we need to split 3x squared into a product where each factor has an x. And the only way we can split it is 3x and another x. So we write 3x in one parenthesis and x in the other one. Now, the other numbers that we have to find, when we multiply them, we have to get negative 4. And the numbers whose product is negative 4 can be negative 1 times 4, or positive 1 times negative 4, or positive 2 times negative 2. In case of negative 1 and positive 4, one option is to have negative 1 in the first parenthesis and 4 in the second one, or vice versa. And that would be 3x plus 4 times x minus 1. Now, another product that makes negative 4 is positive 1 and negative 4, then in this case, in the first parenthesis, we could have 3x plus 1, and in the second, x minus 4, or 3x minus 4 in the first parenthesis and x plus 1 in the second. And now two more numbers whose product is negative 4 are positive 2 and negative 2. Then in this case, we can write 3x plus 2 in the first parenthesis and x minus 2 in the second, or 3x minus 2 in the first and x plus 2 in the second. Now, out of all these products, if we use FOIL, only one will result in 3x squared minus 4x plus 4. And that is 3x plus 2 times x minus 2. And this is because 3x times x is 3x squared, 3x times negative 2 is negative 6x, 2 times x is 2x, and negative 6x plus 2x is negative 4x. Then 2 times negative 2 is negative 4. Now let's see how the sum, product, and grouping works. I will write the same trinomial, 3x squared minus 4x minus 4. Then first, we need to find two numbers whose sum is negative 4. So I will write that the sum has to be negative 4, and the product of these two numbers is not just negative 4, but is negative 4 times positive 3. And negative 4 times positive 3 is negative 12. So to get this product, we need to multiply the coefficient of x squared and the constant. And now two numbers whose sum is negative 4 and whose product is negative 12 are negative 6 and positive 2. If we add these numbers, we will get negative 4, but if we multiply them, we will get negative 12. Next, we will use these two numbers to split the middle term into a sum. So first, I will bring down 3x squared, and in place of minus 4x, using those two numbers, I will write minus 6x plus 2x, and then I will bring down minus 4. So I just split negative 4x into negative 6x and 2x. And now we got a polynomial that has 4 terms, and to factor it, we will use grouping. For this, we will have the first 2 terms in one group and the last 2 terms in another group. And now in the first group, the greatest common factor is 3x, then in parentheses we will have x minus 2. Then in the second group, we will factor out 2, and inside the parentheses we will have x minus 2. Then, because x minus 2 is the common factor, we will factor it out, and inside the parentheses we will have 3x plus 2. So again, this is the common factor, and we brought it down, and in the second parenthesis we brought down 3x and then plus 2. And now the result is x minus 2 times 3x plus 2. Now, the next topic you need to know well before taking a calculus class is exponents. If we multiply expressions that have the same base, then we need to add the exponents. For example, x to the 5th power multiplied by x to the 3rd power equals x to the 8th power. Now, when we divide the expressions that have the same base, we subtract the exponents. For example, x to the 6th power over x squared equals x to the 4th power. If we raise an exponential expression to another exponent, then we multiply these exponents. For example, x to the 5th power raised to the 3rd power equals x to the 15th power. Next, if we raise a product to an exponent, we need to raise each factor to that exponent. For example, 7x to the second power equals 7 to the second power is 49, and then x squared. If we raise a fraction to an exponent, then we need to raise the numerator to that exponent and then the denominator to the same exponent. For example, 4 over x cubed equals 4 cubed is 64 over x cubed. If we raise a non-zero number to the 0 power, we will get 1. For example, 7 raised to the 0 power equals 1. If we have a number a raised to a negative exponent and we move it down to the denominator, then the exponent becomes positive. For example, x to the negative 5 equals 1 over x to the positive 5. If in a fraction we have a with a negative exponent in the denominator and we move it up to the numerator, then the exponent will become positive. For example, 1 over x to the negative 4 equals x to the positive 4. If we have a fraction raised to a negative exponent and we flip this fraction, then the exponent will become positive. For example, 5 over 4 to the negative 2 equals 4 over 5 to the positive 2, or this is 16 over 25. A number a raised to an exponent 1 over n equals the nth root of a. For example, x to the 1/2 equals square root of x, or x to the 1 over 5 equals the 5th root of x. And a raised to an exponent m over n equals the nth root of a all to the m's power, or the nth root of a to the m's power. For example, 8 to the power of 2 over 3 equals the 3rd root of 8 all to the 2nd power, or the 3rd root of 8 to the 2nd power. So both these expressions will give us the same result. In the first one, cube root of 8 is 2 and 2 to the 2nd power is 4, and in the second, 8 to the 2nd power is 64 and cube root of 64 is 4. So the value of this expression is 4. The next topic is functions. These are equations in which for each value of x, we have only one value for y. I will show you 2 examples, and you will see that in the first one, the equation will be a function, and in the second one, it will not be a function. So the first equation will be y equals x squared. In this equation, I will replace x with numbers, and I will find the values of y, and then I will use these values to graph this equation. So here I have a table, and for x I will choose the integers from -3 to +3. Then -3 to the 2nd power is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Now, what we can learn from this table is that each time we replace x with a number, we get only one answer. So, for each value of x, we get only one value for y. And this is what makes this equation a function. Now, I will get the rectangular coordinate system, and now I will plot the points and connect them to get the graph. So here we have the graph of this function, and now let's see an example of an equation that is not a function. For example, x equals y squared. in this equation, I will also replace x with numbers and find the values of y. So here again we have the table. And now notice that to get x, we need to raise y to the second power. And when we raise numbers to the second power, the result cannot be negative. So the smallest value that we can have for x will be 0. So in the table, when x is 0, y is also 0. Then from here, for x, we can choose only positive numbers. For example, let x be equal to 1. Then we need to ask, what do we raise to the second power to get 1? There are two numbers that you can raise to the second power and get 1. The first one is 1, and the second one is negative 1. So again, 1 squared is 1, and negative 1 squared is also 1. So then, in the table, when x is 1, y can also be 1, or when x is 1, y can be negative 1. And now notice that for the same value of x, we got two values of y. And this already tells us that this equation is not going to be a function. Now let's continue with more values for x. For example, let x be 4. Then in this case, y can be 2, or for the same 4, y can be negative 2. And here we see again that for the same value of x, we have two values for y. And let x have one more value, for example 9. Then in this case, y can be 3, or y can be negative 3. Now I will get the rectangular coordinate system and I will graph this equation as well. So now here's the graph of x equals y squared. Now there is a test called the vertical line test that will tell us if a graph represents a function. If over a graph you draw a vertical line, and if this line crosses the graph in only one point, then this graph is a function. But if you draw a vertical line over a graph, and this line crosses the graph in more than a point, in this case in 2 points, then this graph does not represent a function. Now let's talk more about equations that represent functions. So y equals x squared represents a function. Then in this case, in place of y, we can use a function notation. And for this we can use any letter we want. For example, a common letter used for functions is f. So in place of y equals x squared, we can write f of x equals x squared. So in function notation, next to f, inside the parentheses, we write x, showing that x represents the domain of this function. And the domain is all the values that we can have in place of x. And then if we want to evaluate the function, then in place of x, we can write any number we need. For example, f of 5 means that we want to find the value of this function when x is 5. So if we go and replace x with 5, then 5 squared is 25. The next topic is composition of functions and inverse functions. The composition of two functions f and g is a new function formed by plugging the g function into the f function. The composition of f and g equals f of g of x, and the composition of g and f equals g of f of x. So when we take the composition of two functions, it is important what function we write first. If in this notation we write f first, this means that f is the main function and g is just the domain of f. Now in this notation we have g first. This means that g is the main function and f of x is the domain of g. Let's see an example. Let the f function be equal to x squared minus 5, and the g function equals 2x plus 3. First, we will find the composition of f and g. In this case, g becomes the domain of f, and this means that we take the g function and replace it into the x of the f function. Then we will get 2x plus 3 squared and then minus 5. And now to simplify this expression, we will raise 2x plus 3 to the second power. And for this we will use the formula a plus b to the second power equals a squared plus 2ab plus b squared. So then 2x to the second power is 4x squared. 2 times 2x times 3 is 12x. And 3 to the second power is 9. All this minus 5. Then the composition will be 4x squared plus 12x and minus 4. Now, what if we have the same f function that equals x squared minus 5 and the same g function that is 2x plus 3, and we form the composition of g then f. In this case, f becomes the domain of g. So now we will take the f function and we will replace the x in the g function. So in the g function, first we will bring down 2, then in place of x we will write x squared minus 5, then plus 3. And if we distribute, we will get 2x squared minus 10 plus 3, which equals 2x squared minus 7. So this is the composition of f and g, but this is the composition of g and f. Now let's talk about inverse functions. Given a function f of x, the inverse function denoted by f inverse of x is a function that undoes the operation of f of x. The composition of inverse functions equals x. So the composition of f and g equals x, and the composition of g and f also equals x. Let's see an example. Let's say we have the function f of x equals 2x plus 5. First, let's see how we can find the inverse of this function. In the first step, for simplicity, we will replace f of x with y. So we will write y equals 2x plus 5. So this is the same function, and we just replaced f of x with y. But now in the next step, we will find the inverse function, and for this we will interchange x and y. So in place of y, we will write x, and in place of x, we will write y. And this is already the inverse function, and now let's solve it for y. First I will move 5 to the left, so I will have x minus 5 equals 2y. Then I will divide both sides by 2, and on the right side 2 and 2 will cancel, and y equals x minus 5 over 2. So now we have the inverse function solved for y, and now let's replace this y with the notation for the inverse function f inverse of x. So in place of y, I will write f inverse of x equals x minus 5 over 2. So the inverse of the function 2x plus 5 is x minus 5 over 2. Now, the definition also tells us that if we have two functions that are inverses of each other, and we take the composition of these two functions, we will get x. So the initial function is f of x equals 2x plus 5, and the inverse function is f inverse of x equals x minus 5 over 2. And if we take the composition of f, then f inverse, then we will take the f inverse function and put it in place of x in the f function. So then we will have 2 times x minus 5 over 2 and then plus 5. Then here 2 and 2 will cancel, and x minus 5 plus 5 equals x. So indeed, the composition of f and f inverse is x. But now let's also check if the composition of f inverse and f is also x. So again, the initial function f of x is 2x plus 5, and the f inverse is x minus 5 over 2. And now we need the composition of f inverse, then f. In this case, we will take the f function and we will put it in place of the x of the f inverse function. So then, we will start with a fraction, and in place of x, we will write 2x plus 5, then minus 5, then over 2. In the numerator, 5 minus 5 is 0, then 2x over 2 equals x. So again here the composition is x. The next topic is reading graphs. So here we have a graph and we need to answer all these questions. The first one is the domain of this function. To find the domain from a graph, we need to see how far the graph extends to the left and how far extends to the right. And it appears that this graph extends infinitely in both directions. So then, we can say that the domain of this function is negative infinity to positive infinity. Now, to find the range, we need to see how far the graph extends down and how far it extends up. From this graph, it looks like the lowest point is negative 2. However, this graph extends infinitely upward. So then, to write the range, we will use bracket negative 2, comma, infinity, parenthesis. And we use the bracket to show that negative 2 is included. However, when we write the infinity symbol, we always use parentheses. Next, the x-intercepts are the points where the graph crosses the x-axis. And these are negative 5, negative 1, and positive 3. So we will write negative 5, negative 1, and positive 3. The y-intercept is the point where the graph crosses the y-axis, and in this case is 2. So we will write that the y-intercept is 2. Next, we need to find the local minima. On this graph, these are the lowest points in each valley. So in this neighborhood, the lowest point is negative 3, negative 2, and in this neighborhood, the lowest point is 3, 0. So one local minimum is negative 3, negative 2, and the other one is 3, 0. The local maxima is the highest point on each hill. On this graph, here we have a hill, and the highest point is 1, 3. So we have one local maximum, and that is 1, 3. Next, we need the intervals where the function is increasing or decreasing. If we look at this graph from left to right, we see that first the graph is decreasing, and then increasing, then again decreasing, and again increasing. If we move along the x-axis, then we can say that first the graph is decreasing from negative infinity to negative 3. Then it is increasing from negative 3 to positive 1. Then again decreasing from 1 to 3, and increasing from 3 to infinity. So the function is increasing from negative 3 to 1, then from 3 to positive infinity. And when we write the intervals where the function is increasing, always use parentheses. So the first interval will be from negative 3 to 1, and the second from 3 to positive infinity. Then the function is decreasing from negative infinity to negative 3, then from 1 to 3. And again, when we write the intervals, we will just use parentheses. So negative infinity, negative 3, and 1 to 3. Next, we need the value of the function when x is 2. And from the graph, when x is 2, the value of the function appears to be 1. So we will write 1. And in the last question, we need all the values of x for which the function is less than 0. On the graph, this is the interval where the function is below the x-axis. And this interval is between negative 5 and negative 1. So we will write parentheses, negative 5, comma, negative 1. And we use parentheses because we don't want to include these numbers, because at negative 5 and negative 1 the function is 0, but we need the values of x for which the function is less than 0. The next topic is logarithms. A basic logarithmic function has the form y equals log base b of x. This function is the inverse of the exponential function. In a logarithmic function y equals log base b of x, b represents the base and it has to be positive and not equal to 1. Y represents the exponent and x represents the result. So a logarithmic function is the exponent to which the base b must be raised to get the result x. For example, log base 5 of 25 equals 2. And this is because the base 5 raised to the second power equals 25. So 2 is the exponent and 25 is the result. Now below we have 4 basic properties of logarithms. The first one is log base b of b equals 1. For example, log base 5 of 5 equals 1 because 5 to the first power equals 5. In the next property, log base b of 1 equals 0. For example, log base 5 of 1 equals 0. And this is because 5 to the 0 power equals 1. Next, log base b of b to the x power equals x. For example, log base 7 of 7 squared equals 2. And indeed, 7 to the second power equals 7 to the second power. And the last one, b to the log base b of x equals x. For example, 3 to the log base 3 of 9 equals 9. And that is because log base 3 of 9 equals 2, because 3 to the second power equals 9, and if this logarithm is 2, then 3 to the second power equals 9. And notice that these two properties are the compositions of the logarithmic and the exponential functions. And because these two functions are inverses of each other, the result of the composition is x. Now, if a logarithm has base 10, then we call it a common logarithm and we write log of x. But if a logarithm has base e, then we call it a natural logarithm and we write ln of x. 3 important properties of logarithms are the product rule, the quotient rule, and the power rule. With the product rule, we can write the logarithm of a product as the sum of 2 logarithms. So log base b of x times y equals log base b of x plus log base b of y. With the quotient rule, we can write the logarithm of a quotient as a difference of 2 logarithms. So log base b of x over y equals log base b of x minus log base b of y. And with the power rule, if the expression under the logarithm has an exponent, then we can move that exponent in front of the logarithm. So log base b of x to the power of c equals c times log base b of x. Let's see an example. Let's say we have log base 2 of x cubed square root of y over z, and we need to expand this logarithm. Because in this logarithm we have x cubed times square root of y divided by z, first we will apply the product rule and the quotient rule. So in the first step we will write log base 2 of x cubed plus log base 2 of square root of y minus log base 2 of z. So again, log base 2 of x cubed plus log base 2 of square root of y minus log base 2 of z. Next, we see that x has exponent 3, and we can write square root of y as y to the power of 1/2. So let's rewrite y. So now we will have log base 2 of x cubed plus log base 2 of y to the 1/2 minus log base 2 of z. And now in the last step, we will apply the power rule and we will move each exponent in front of the logarithm. So then we will have 3 log base 2 of x plus 1/2 log base 2 of y and minus log base 2 of z. The next topic is geometry. A few formulas that you might need will be the Pythagorean theorem as well as the area and the volume of some geometric figures. The Pythagorean theorem tells us that in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. That is a squared plus b squared equals c squared. The area of a rectangle is length times width. The area of a triangle is 1/2 times the base and times the height. The area of a parallelogram is the base times the height. The area of a trapezoid is the height divided by 2 times the sum of the bases. The area of a circle is pi times the radius squared. The volume of a right circular cylinder is pi times the radius squared times the height. The volume of a right circular cone is 1/3 times pi times radius squared times the height. And the volume of a sphere is 4/3 times pi times radius cubed. The next topic is the trigonometric functions. In a right triangle, sine of an acute angle A equals the opposite side A divided by the hypotenuse C. Cosine of angle A equals the adjacent side B divided by the hypotenuse C. Tangent of angle A equals the opposite side A divided by the adjacent side B. The other three trigonometric functions are reciprocals of the first ones. So the cosecant function is the reciprocal of sine, and if sine is A over C, then the cosecant is C over A. The secant function is the reciprocal of cosine, so if cosine is B over C, then secant is C over B. And the cotangent is the reciprocal of tangent, and it is B over A. Now, the trigonometric functions can also be defined for any angle. So here we have a point in the rectangular coordinate system, and this point is located on the terminal side of angle theta. In this case, angle theta is an obtuse angle. Then, if from this point we draw a perpendicular down to the x-axis, then we have formed a right triangle. In this triangle, this side is y, this side is x, and the hypotenuse is r. Then for any angle theta for which the trigonometric functions are defined, sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, cosecant of theta is r over y, secant of theta is r over x, and cotangent of theta is x over y. Now, depending on the quadrant, x or y could be positive or negative, and r is always positive. And this means that depending on the quadrant, the trigonometric functions could be positive or negative. In quadrant 1, where both x and y are positive, all 6 trigonometric functions are positive. In quadrant 2, x is negative and y is positive, therefore sine and cosecant are positive, but cosine, secant, tangent and cotangent are negative. In quadrant 3, both x and y are negative, therefore sine, cosecant, cosine and secant are negative, and tangent and cotangent are positive. And in quadrant 4, x is positive and y is negative, therefore sine, cosecant, tangent and cotangent are negative, but cosine and secant are positive. The next topic is the unit circle. The unit circle has the center at the origin of the rectangular coordinate system, and the radius of this circle is 1. The circle usually shows 16 angles, and they are given in both degrees and radians. All the angles have the initial side along the positive x-axis. This unit circle displays positive angles, but we can also have unit circles with negative angles. So if from the initial side we move counterclockwise, we generate positive angles, but if we would move clockwise, we would generate negative angles. Now, each of these angles correspond to a point on the unit circle. For example, for the 60-degree angle, the corresponding point has the coordinates 1/2 and square root of 3 over 2. Now, recall that this is how the 6 trigonometric functions are defined using a point in the rectangular coordinate system. If we pick a point on the unit circle, for example this one, and we draw a perpendicular down to the x-axis, then we will form a right triangle. In this triangle, this side is x, and it is square root of 3 over 2. This side is y, and it is 1/2, and the hypotenuse r equals 1 because the radius of this circle is 1. So if in these formulas we replace r with 1, then we get the following. Sine of theta equals y, cosine of theta equals x, tangent of theta equals y over x, cosecant of theta is 1 over y, secant of theta is 1 over x, and cotangent of theta is x over y. So if sine of theta equals y and cosine of theta equals x, then on the unit circle, the x-coordinate represents the cosine of the given angle, and the y-coordinate represents the sine. So again, x represents cosine and y represents sine. For example, we can say that sine of 3 pi over 4 equals square root of 2 over 2. Cosine of 270 degrees is 0. Sine of 240 degrees is negative square root of 3 over 2. And now the last topic I have for you is the trigonometric identities. Although you might need all of them, I will circle for you the ones that you will encounter more often. First, you will need the reciprocal identities, then the quotient identities, and these are tangent of x equals sine of x over cosine of x, and cotangent of x equals cosine of x over sine of x. Also frequently used are the Pythagorean identities, and these are sine squared of x plus cosine squared of x equals 1, 1 plus tangent squared of x equals secant squared of x, and 1 plus cotangent squared of x equals cosecant squared of x. Next, you will need the double angle formulas. And these are sine of 2x equals 2 sine of x cosine of x. Cosine of 2x has three formulas, and the first one is cosine squared of x minus sine squared of x, or 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. Tangent of 2x equals 2 tangent of x over 1 minus tangent squared of x. And you will also need the power reducing formulas. The first one is sine squared of x equals 1 minus cosine of 2x over 2. Cosine squared of x equals 1 plus cosine of 2x over 2. And tangent squared of x equals 1 minus cosine of 2x over 1 plus cosine of 2x. So here you have all 12 topics you need to know before starting your first calculus class. Thank you for watching.